All right, this is going to be on 5.5, properties of log. So let's just look back at the basic definition of log again. All right, so if you have log of base a of x equals to y, and that means a to the y equals to x, right? Just remember this whole big circle, a to the y equals to x. And the argument is what is equal to, and y is the exponent, okay? That's log form, that's exponential form. They're both the same thing. They're equal. They're saying the same thing, okay? And these are some properties of log that we got to learn. Log of any base of 1 is equal to 0 because a, or anything to the 0 power is equal to 1, okay? A to the 0 power is 1. So let's use that, right? This one, basically, log base 5 of 1 is equal to something. Basically, it's asking 5 to the what gives you 1. Well, it doesn't matter what 5 is. Anything to the 0 power is 1, so it's had to be equal to 0. Okay? Log of 27.43 of 1 is equal to 0. Anything to the 0 power is 1. So it's always, if your argument is 1, the answer is always going to be 0. Next property, the identity property. Log base a of a is always equal to 1. Right? If your base and your argument is the same, it has to be 1. Right? The power has to be 1 for it to stay the same. So a to the first power is equal to a. So example, 5 to the what power gives you 5? Well, it's 1. Right? 27.43 to the what power is 27.43? First power. All right, here we have some inverse properties, and I think of them as the same base property. Here you have a raised to the log base a of x equals 2, has to be x. Okay? Now this looks really confusing, but if you just cover up that exponent, consider that that exponent is like that green box. Now we change this into log form. So it has to be log base a of x equals to the green box. Now that green box has to be then log base a of x, right? Log base a of x is equal to log base a of x. So how do we use that? Well, 5 to the log base 5 of 13 has to be equal to 13. Okay, just use the formula, okay? If it looks like it could be used from what other properties, we use it. Okay, log 144.5 raised to the log base 144.587 has to be equal to 87. All right. Here, another inverse property here. Again, think of this as the same base, right? Log base a of a raised to the r has to be equal to r. Right? This is kind of easy to see. You switch it to exponential form. A to the what equals to a to the r? Well, a to the r. So here, log base 4 of 4 to the 5th power is equal to 5. Like it's 4 to the 5th power is equal to 4 to the 5th power. Again, same thing here. Same base and same argument raised to something has to be equal to that something, equal to that exponent, so equal to 52. Now, these are the really important ones. You will see these on the test. So really make sure you learn these, all right? If you have log of the same base that are adding together, then you can multiply their arguments together, like n and m, okay? Remember that we learned this in Algebra 2. This is a review for you guys. So here, I have log base 4 of 2 plus log base 4 of x squared. You can multiply these guys, the argument, 2 and x squared, equals to log base 4 of 2 times x squared. Okay? You can go backwards. Log base 7 of 2 things that are multiplied together, you can split into 2 things that are 2 log that are added together. So it's log base 7 of 5 plus log base 7 of x. And you can try to simplify this further. Can you simplify log base 7 of 5? No, 7 to the what power gives you 5? That's hard. That's a decimal thing. That's a calculator thing. You can't do it. Okay. If this was like a 49, you would have, oh, that becomes a 2. 7 to the second power is 49, you know. Yeah, if this 5 was a 49, you would have to simplify it more. Here's a common mistake to avoid. Some people tend to distribute the log into the argument. That does not work. Okay, don't do that. Difference of log. Here, the opposite thing, instead of adding, you have subtraction. If you have subtraction, then the n and the m, the arguments, they divide, okay? And there's this whole, if you work this out, it's not hard to see why this is, right? Because these things are the exponents. Log is basically asking you what is the exponent. And you subtract the exponent, you basically have to divide the argument. If you divide, you subtract exponent. That's why. But an example here, if you have subtraction, as you see log of the same base, right? Whichever positive stays on top. So the 2 goes on top. And this x squared here, the log is negative, so it goes at the bottom. So you have log base 4 of 2 divided by x squared because it's a subtraction in front of it, right? So the argument goes at the bottom. Now you go backwards. If it's at the bottom, it's a negative log. It's on top, it's a positive log. So positive log base 7 of 5 minus log base 7 of x. Okay, x is at the bottom, so it's a subtraction. Common mistake to avoid here. You see subtraction here, and they put log of this over log of that. No, it's the log of the argument divided by each other. Okay, so that one is wrong. And another important one here is the product of log. So if you have like log base of something raised to the power, you can bring that power to the front and multiply it. So r times log base a of n. Okay. And the example would be like if you have log base 4 of x squared, you can take that, the 2 goes to the front. Okay, so you have 2 times log base 4 of x. You can go backwards. If there's a number multiplied to your log, that can be applied as an exponent of your argument. So it becomes log base 3 of x to the 1/2. And x to the 1/2 is square root of x. Same thing. Square root is exponent of 1/2. Common mistake to avoid here. This exponent applies to the whole entire log, not just the argument. So you can't bring it to the front. This is wrong. Okay. Some examples. We have to evaluate these guys. So log base 3 of square root of 81. Now you think of square root of 81, that's actually 81 to the 1/2, and I move 1/2 to the front. Okay. Now I think, oh, what is log base 3 of 81? Well, I make the bases the same, and this becomes the same base property, right? So this becomes 4. So 1/2 times 4 is 2. Alternately, you can solve it like this. It's just make it equal to x, and then 3 to the x equals the square root of 81, which is 3 to the x equal to 9, x equals to 2, same thing. Log base 3 of 108 minus log base 3 of 4. They're the same base, so you can basically, this is subtraction, so it's this divided by that, right? So log of 108 over 4. 108 over 4 is 27. And here you can simplify this, right? 3 to the what power gives you 27? 3 to the third power. So it has to be equal to 3. Okay, so a problem like this here, you gotta kind of be able to do it in your head pretty easily now. You gotta think, oh, base raised to the what power gives me this number. 3 times 3 is 9, times 3 is 27, so it's 3. Here you have more of the same thing, but there are 3 of them. So remember, this one is, first one is positive, it goes on top. Negative goes to the bottom, positive goes on top. So 48 over 3 times 4, all in the same log. See, 48 is positive because the log is positive. The 4 is on top because it's positive here. So they're both on top. The only one that goes to the bottom is the negative log, so the 3 goes to the bottom. You simplify that, you get log base 4 of 64. Now think about this. 4 raised to the what gives you 64? I think third power. 4 times 4 is 16 times 4 is 64. Yeah. 4 times 4 is 16 times 4 is 64. So you can simplify this. Now, if this number was like a 5, 5 can't give you 64. So you can't simplify that. That's when you need a calculator. Okay. We'll talk more about that later. Another problem here. 2 raised to the what gives you 8 to the 33. Well, you move the 33 to the front. Now you have 33 log base 2 of 8. Now here, log base 2 of 8 is easy. 2 to the what gives you 8? 2 to the third power. I see. 2 to the third power. So that just gives you 3. 33 times 3 is 99. Now let's solve some more of these here. You see this log here, it had 25 times x. I can break that up. Log base 5 of 25 plus log base 5 of x. Because they're multiplied, you split into log that are adding. Now here, 5 raised to the what gives you 25. This, you can simplify this to become a 2. And this one, you can't do anything to it. So it's 2 plus log base 5 of x. Here, log 15 to the third power. Log is log base 10, right? So I bring the 3 to the front. 3 times log base 10 of 15. 10 to the what gives you 15? You can't do it. At this point, you would need a calculator to make it, to solve it some more, right? To get a more exact answer. You can't. So you leave it like this. That's it. The difference between this and this here is that this one you can do in your head. 5 to the what gives you 25. Second power. Here, 10 to the what gives you 15. Can't do it. This one you break it out. Okay, things that are multiplied, bring the x and the y apart, becomes log plus log because they're both multiplied, right? And here you have x squared, so you're going to move the 2 to the front. So 2 log base 7 of x plus log base 7 of y. Same thing here, you know. Log base 6 of y plus log base 6 of square root of z. That's all we can do. Oh yeah, I can bring the 1/2 to the front because z to the 1/2 here. Z square root of z, remember square root is 1/2 exponent. So bring the 1/2 to the front and then you're done. This thing here, because it's division, the top is positive, the bottom is negative. Okay. And then you split this out some more, ln of 6 plus ln of x squared minus ln of y to the fourth. And then move the exponent off to the front. So ln of 6 plus 2 times ln of x minus 4 times ln of y. Here I moved, so cube root is now exponent of 1/3. So I moved the 1/3 to the front and ln of these guys. And I split these guys out like that. 3. And then r squared is 2 times ln r plus ln s. Okay. Here you want to combine them. So ln of 12 minus ln of 4. Subtraction, so you're actually dividing. So ln of 12 over 4, which is ln of 3. And I would need a calculator to do this. So I stop there. Same thing here. This is an exponent, so move the 2 to on top. So log of 6 squared plus log base 5 of 2 minus log base 5 of 2 cubed. Move the 3 to the exponent. All right. Now, because they're adding and subtracting, you can combine them into multiplying and dividing. So positive goes on top, so 6 squared on top, and the 2 goes on top. Oh, I multiplied this out, so I get 36 and 8. See, okay, positive is 36 and 2, they go on top. The negative log, the 8 goes at the bottom, like that. 36 and 2 on top, 8 at the bottom. And then you simplify that, you get log base 5 of 9. Here, can I do any more? 5 to the what power gives you 9? 5 times 5 is 25. It doesn't give you 9, so you stop there. If you want to do more, you need a calculator for that. Okay. This one, I move the 7 up here, become exponent. I move the 4 up here to become y to the fourth. And I combine them. They're all positive, so they all multiply together. Oh, this problem. I move the 6 in here to become the exponent. Remember, you can't distribute the ln, okay? So 6 becomes the exponent of this argument here. So ln of this thing to the 6 plus ln of this thing to the 1/2. And 1/2 is square root, right? And then since you're adding, you got to put them together. But instead of the root now, I'm just going to leave 1/2 because this one has exponent. And this one should have exponent instead of root. And this last problem here is left as an exercise for you. Now, remember the problem that we can't do it, and I said we have to use a calculator. We have to use the change of base formula, okay?